So, this class we will be discussing about seismic force calculation. This will be calculated as per this IS code. This IS code number is 1893, 1893. This is revised in 2002. There is appendix B in which this figure is given. How many of you have seen this map before? Civil engineering students? Huh? Nobody has seen this map. How many of you have seen India map? I am really asking, have you seen India map? Huh? Okay, what is this part? What is this? Huh? This one? So these are also part of India. So there are different colors given. Can you identify the color? Blue, then it's really pink, light pink. Okay. What does it mean? Which is very severe earthquake zone? I don't know whether you are able to see this. You are able to see what is this zone? Zone 5. It starts from zone 2. So you have a earlier figure 1893. I will show it towards the end of my PowerPoint presentation. There we have zone 1, zone 2, zone 3, zone 4, zone 5. India is divided into 5 zones, right? But now India is divided into only 4 zones. The zones are zone 2, zone 3, zone 4 and zone 5. You can compare and see that most of the zones are, most of the places are upgraded to one zone above. So this blue color you can see, these are all the zone 2 where the intensity is less. Then the pink color, the intensity is high. Where are the pink colors in India? Gujarat, northeast, then Andaman Nicobar Islands. You are missing the important thing. Pink color is shown elsewhere also. What is it? Not only northeast. That is the Himalayan belt. This all these locations, no? These are all part of Himalayas. Okay. Then green color is zone 4. These are all Himalayan regions only. So there it is susceptible to a lot of seismic activity. Then we have the yellow colors. Mostly yellow color is in the coastal region, and there is a connection here between these two. So yellow color is zone 3. Lakshadweep Island is in zone 3, not in zone 5. So this seismic force controls the design of the structure if it is in zone 5 or zone 4. So where we have earthquake, which port we had earthquake? Recent times. What are the 2 earthquakes that has occurred very recently? Earthquake is occurring every day, every year also it may be there. 2 severe earthquakes in this decade. What are they? Bhuj earthquake, then another earthquake. You know tsunami, right? When did it happen? Why it happened? 2006, 2004. Why it happened? Bhuj, when it has happened, Bhuj earthquake? 2001. Okay. When did it happen? What day? Jan 26. What about tsunami? December? I don't remember. Okay. Tsunami, why did it happen? It also happened because of earthquake only. What intensity? 9.2 or 9.3. What is the maximum value? Earthquake? 10. Bhuj earthquake? It is only 7.2, 7.3. See this tsunami has taken place in Indonesia, that island is very close to this tip of Indra Point. There is a point here which is called as Indra Point, tip of Nicobar Island. But earthquake occurred all along this plane also. There is a fault line which goes like this. It happened all along this. Earthquake happened not only at Indonesia, northern tip of Indonesia, it has happened in Port Blair also. You are aware of this or you do not know that? You do not know. That is a major earthquake that has happened in recent times. Whenever you see the code, you will be getting this information. You have to read. How many of you have read any code? Huh? Any code? What code you have read? IS 800.
IS 456.
You have not studied IS 890, 1893. How to get these codes? You know how to get? Please try to use it. If you are going outside, you may not be able to get all these codes. There is list of IS codes which are to be used. I saw it today somewhere, which are useful. Please download and put it in the memory stick. You can download all the IS codes. Please do it. If you go outside, if you are going for a software company job or a management job, do not do it. If you want to do core engineering, you please download. The mechanical engineering also, there are a lot of codes which you can get it from IIT. Very difficult to get outside. When I studied, I bought all these codes paying money. There is a parameter given here, SA by G. This is called as average response acceleration coefficient. This we will be using. R is the response reduction factor. This also we will be using. The design. This T is given, this is called as undamped natural period of vibration of the structure in second. What is natural period? What is natural period? You know what is natural period? You say yes or no, only two answers are there. Huh? I think you are keeping quiet means you know something and you do not know completely. You have not studied what is natural period. Omega is equal to root of k by m. How many of you know? Huh? You are all civil engineers. Mechanical engineer also should know. How many mechanical engineers? Raise your hand. You also should know. You have not studied omega is equal to root of k by m. Huh? Studied or not studied?
Yes, sir.
Mechanical.
Yes, sir.
What is omega? What is k? Stiffness. M is mass. That frequency omega is equal to 2 pi by t, that t is your natural period. I will tell you after some time how to calculate that for a cantilever. For a cantilever, how to calculate the natural period? Have you done any problem? Not done. Okay, I will tell you. So this AH is the called as the seismic coefficient, that is called as a design horizontal seismic coefficient. Seismic coefficient, you know, horizontal means in the horizontal direction. What is design? Always we use what is design. This design means what you use it for the design purpose. It can be more than the probability of occurrence and less than the probability of occurrence. In this case, we use Z by 2. Z is the zone factor, that divided by 2, that is what we use. this is a design basis earthquake, that is Z by 2. It is likely that the maximum earthquake coefficient can be Z, but we are using only Z by 2. So if the structure fails, do not go and kill the engineer, because doctors and all they are killing, we do not design. Is it clear? We do not design it for the maximum credible earthquake. Maximum credible earthquake is equivalent to Z. What we are doing is for Z by 2. Kudangulam power plant is designed for Z, or they might have designed even more than Z. Most of the temples which have survived so many earthquakes and tsunamis in India, they are all designed for very high earthquake coefficients. So if you see the palaces of South Indian princes, now no palace is available except this Tirumala Nayakar Mahal, whereas most of the temples are existing because they have assumed a very high factor of safety. I is the importance factor, here only it comes into picture. Importance factor can be 1 or 1.5. So if it is a very important structure, we use the importance factor of 1.5. R is the response reduction factor. This depends on the ductility of the system. SA by G is the seismic coefficient, that depends on the natural period of the system. SA is seismic acceleration and is normalized with the acceleration due to gravity. Zone factor is given in table 2. This is for the maximum considered, I said credible, that is not correct, maximum considered earthquake and service life of structure in a zone. The factor 2 in the denomination of Z is used so as to reduce the maximum considered earthquake zone factor to the factor of design basis earthquake. I will ask these questions, what is MCE and what is DBE? We have to explain what is MCE and what is DBE. Importance factor I already applied, it is depending on the hazardous consequences of its failure. Water tanks are designed for very high importance factor, schools, public buildings, libraries, temples, common markets. We have to design for malls also, because most of the people are there in the mall, and hazardous consequence of its failure means dams. If there is a failure of a dam, it will create lot of problem. So those things we have to see. Post earthquake functional needs, what do you need after earthquake? What building you need after earthquake? What building you need to survive after an earthquake? Huh? Hospital. Hospital is required. So hospital is to be designed for historical value. What is the historical value? How many monuments are there in Chennai? Historical value. Huh? Have you seen any historical building in Chennai? Huh? No building is there. All of you might have passed through that building. Huh? Central Station. Central Station is a historical building. Any other building? Recently there was a fire accident. Which building? Chennai, there was a fire accident in one of the buildings. Which building it was? Ezhilagam, you do not read the newspaper and all. Ezhilagam, have you seen where it is? See, there are many buildings with just opposite to our IIT campus there is a historical building. What is that? Anna University, Guindy Engineering College building is one of the historical buildings. There is a footnote which you should see. The ratio of I by R shall not be greater than 1. Okay. This you have to see. Do not substitute some values and get I by R greater than 1. This is the zone factor Z. Zone factor Z is zone 2, zone 3, zone 4, zone 5. The values varies from 0.1, 0.16, 0.24 and 0.36. These are the values. Then we use this graph. Whenever you want to present a graph, you will be making some presentation in future also. Whenever you do, you define what is the x axis. What is the x axis? Period means natural period of the structure in seconds. What is the range given? What is the natural period range given? What is the range? 0 to 4 seconds. Most of our berthing structure will be very close to 1 second. What is the natural period of jacket platform? MTech Ocean Engineering, you studied, no? What is the natural period?
2 to 4 seconds.
If it is very close to 4 seconds, no, then we have to consider dynamics. Most of the platform are between 1 and 2 seconds only. With increase in water depth, what will happen to natural period? It will increase. Omega is equal to root of k by m. So I will discuss later. What is the maximum? What is y axis? This is called as spectral acceleration coefficient, SA by G. What is the maximum value? 2.5. The spectral acceleration can be 2.5 times the acceleration due to gravity. We need very less value. Suppose somewhere here it is better. They do not give more than 4. That does not mean your natural period will not be more than 4. It means it is asymptotic. The value will not increase further. The minimum value will be somewhere around 0.2. What are these 3 curves? These 3 curves are depending on the type of soil. Whether the soil is rock, medium soil or soft soil, depending on that the curve will change. Where do you want the natural period of the structure? Where don't you want the natural period of the structure? We do not want the natural period of the structure somewhere here. Then we will have very high seismic acceleration coefficient. So we do not want to have it here. So if the soil is soft soil, it has suppose you take 1 as a period and go vertically here. What happens? If it is a rock, it is near about 1. If it is soil, it is near about 1.8. So the better the soil, your seismic acceleration coefficient will be lesser. How many of you know damping? What do you understand by damping? How many of you know this equation? You have not studied this equation. Mechanical engineering, you have not studied? Studied or not studied? Everybody studied. What is M? What is C? What is K? What is critical damping? You have studied this equation? critical damping is C is equal to 2 into root of mk. M is mass. What is the unit of mass? What is the unit of stiffness? Kilonewton per meter. What is the unit of x? Meter. What is the unit of x dot?
Meter per second.
Meter per second. Unit of x double dot? Meter per second square. So C will be kilonewton divided by meter per second, M will be kilonewton divided by meter per second square. So if you multiply with x double dot, it will give kilonewton. Multiply with x dot, you will get kilonewton. If you multiply with x, you will get kilonewton. Force also is kilonewton. What is the unit of this M into K? You multiply, what you will get? What will you get? You do it, yeah, simply you have a notebook, you write something, you multiply. What is the unit for M? M is kilonewton divided by meter per second square, K is kilonewton per meter. So this will become kilonewton per square by meter square by second square. If we take a root of that, it will become kilonewton by meter per second, right. Whenever you write any derivation or equation, you check the units. This is a very simple way of doing it. If you do not get it properly, then there will be a problem. So what is written here is what is written here? Damping percent, 5% damping, the factor is 1. So the whatever SA by G you have got, this is for a particular damping, that damping is 5%. I have derived a curve, right, we have shown a curve just now. That curve, the SA by G, the values are given for 5% damping because the factor is 1. If the damping is less, what will happen? The acceleration coefficient will increase. The damping is more, the acceleration coefficient will come down. So this percentage is related to the critical damping. C is equal to this percentage damping multiplied by critical damping. Any doubts? Or see what we here we have written is C is equal to some percentage damping multiplied by C critical. So damping is so low, 5% damping is normally used. What about offshore structures? In water will have higher damping or lower damping? You have a structure in air, you have a structure in water, which will have more damping? Water will have more damping. So if the structure is 5% damping, in water it will be about 10%, or sometimes some floating platforms may have even 20% damping. So another thing what we have to see is this response reduction factor. So we have written that equation AH is equal to Z by 2 I by R SA by G. This SA by G depends on the natural period of the structure, it depends on what else? What is it? Damping. Z is depending on the zone, I is depending on the importance. Now we are seeing this factor R. So your seismic force, horizontal force is given as AH multiplied by dead load plus 50% of live load. So, this is what we have to now see. To calculate the horizontal force due to seismic, there is a vertical force also that you will see later. Horizontal force depend on all these factors and you have to calculate that. So, if it is ordinary RC moment resisting factor frame, this is 3, special frame means it is 5, steel frame with concentric braces 4, eccentric braces 5. This masonry walls and all 1.5, very low, unreinforced, with the reinforced is 2.5. So, this is the intensity which you have to see. If the uniformly distributed floor load is 3 kilonewton per meter square, then we can take 25%. If it is more than 3 kilonewton per meter square, it is 50%. What is the minimum live load on a berthing structure? What is the minimum live load? I have shown a table also. What is the range of live load uniformly distributed in a berthing structure? Hmm? 10 kilonewton to 50 kilonewton per meter square. So, you have to use this. There are some approximate formulas given here to calculate the natural period, that we will see later. So, this is how this code has been derived. So, you have seen the water tank, you will have a mass at the top and the height, let us say, is about 20 meters, designed for 100,000 liter, 100,000 liter means 100,000 kg mass. Have you seen water tank in IIT campus? Huh? Where are the water tanks? Near Jamuna Hostel then? Huh? Where?
CRC.
CRC complex. So, that water tank is something like this, it is a single tower. So, BSB only you are telling, no?
Yes,
Your BSB, it is like this. Height will be 20 meters or more, take it as 30 meters. How to let us, I am assuming it is 100,000 liter capacity and the mass is 100,000 kg. Where is this? How to calculate the stiffness for this? K is equal to P by delta. Suppose you assume a point load here, find out the deflection. I will assume unit load divided by delta. What will be the deflection for a cantilever? PL cube by 3EI. So, K will be 3EI by L cube. What is E? 5000 root of FCK. Assume that grade of concrete is M30, then FCK will be 30. I means you have to find out this is a shaft, we take the section of the shaft be like this, maybe 3 meter in diameter, thickness may be about 0.5 meter or something like this. So, from this you can calculate the moment of inertia, substitute K here, M here. What is the unit of this? This will be kilonewton per meter, mass will be kilonewton per meter per second square. So if you, this will be 1 by second. Something is wrong here or what? Correct only, you will get 1 by second. T will be 2 pi by omega. This is how you have to calculate the period. For any structure you can calculate like this. So this is what we are doing. Ah is equal to Z into I by Z by 2 I by R into SA by G, the average response acceleration coefficient. See, whatever figure I have given there, now I am giving in terms of equation. Between 0.1 and 0.4 seconds the coefficient is 2.5, less than 0.1 it increases linearly 1 plus 15t, and after 0.4 it reduces 1 divided by t. Here it is 1.36 by t, here it is 1.67 by t. Mostly you will be using these factors. And I was telling you about the old zone, there it is given zone 1, zone 2, zone 3, zone 4 and zone 5. So the zone 5 remains the same whatever it is. All these zone 1s they have become zone 2, there is no zone 1. I think this is zone 2 is given, this some portions have become zone 3. So tomorrow's class we will try to carry out some studies, calculations for berthing force, mooring force and seismic force. For a typical structure I will tell you how to calculate, you come to ocean engineering department. Okay.